The overall goal of the following experiment is intraoperative detection of the sentinel lymph node in cervical cancer or vulvar cancer. The sentinel lymph node is the first draining lymph node from a tumor. In this procedure, a fluorescent agent, indocyanine green, or ICG, is injected together with the standard blue dye around the primary tumor. The solution will be propulsed to the first draining lymph node. A custom-made intraoperative multispectral fluorescence camera system that is installed in the operating room prior to surgery records real-time in vivo events of lymph flow based on fluorescence signal. Based on in vivo as well as ex vivo results indicating the strength of the fluorescence signal and the classical blue discoloration detection method, the surgeon is guided in excision of the sentinel lymph node.
The main advantage of this technique over existing methods is that it's a one-step procedure during which the visualization and excision of lymph nodes takes place during the surgery.
This platform technology may improve current concepts in surgical oncology, not only by providing the surgeon with anatomical information, but at the same time delivering dynamic, real-time fluorescence tracing in vivo.
In order to perform this protocol, set up the intraoperative multispectral fluorescence camera, which is typically customized. The system shown here was developed at the Institute for Biological and Medical Imaging in Munich in close collaboration with Surgoptics. A laser is used for excitation of the fluorescent probe. The filters of the camera are adjusted to near-infrared fluorescence with an excitation wavelength at 750 nanometers and emission wavelength of 800 plus or minus 20 nanometers. Upon emission, light passes through the optic system where it will separate into visible light, intrinsic fluorescence, and near-infrared fluorescence. The CCD cameras are aligned to detect the separate light bundles so that the multispectral signals from all cameras are processed to yield true quantitative fluorophore biodistribution. This setup also corrects for artifacts. The computer monitors on the control desk and within the OR can display color and fluorescence signals as separate images, as well as superimposed into one image. Under sterile conditions, prepare the fluorescent contrast agent indocyanine green at a concentration of 0.5 mg per milliliter in sterile distilled water. Do not use saline solution as this precipitates the reagent. Immediately store the solution in a dark, cool place in order to prevent bleaching and preserve the integrity of the ICG reagent. In order to minimize interference with the standard surgical procedure, position and initiate the camera system in the operating theater prior to surgery, and check connections to the high-definition screens for use during surgery. Cover the camera in standard sterile drapes using sterile procedures and conditions as shown in the video. Prior to injecting the fluorescent agent, position the camera above the patient and expose the field of interest. Adjust the zoom to focus the camera, and switch off lights in the operating theater for better detection of the fluorescent signal. Load a syringe with 1 milliliter of 0.5 milligrams per milliliter ICG and equal volume of standard blue dye. Carefully inject the fluorescent agent in 4 quadrants around the primary tumor and try to prevent spilling. In case of spillage of ICG on surgical gloves, simply change gloves. Throughout the procedure, maneuver the camera to ensure continual recording of the area of interest. Acquire still images or real-time videos of the lymph flow and the appearance of the fluorescent sentinel lymph node. An exposure time of 180 to 200 milliseconds will yield good videos. Save all data on the computer accordingly for future analyses. Visual inspection for blue discoloration caused by injection of patent blue is performed as a standard part of the procedure. Using the simultaneously recorded fluorescence images for guidance, real-time excision of the sentinel lymph node is performed. Real-time imaging helps to detect fluorescent nodes in unexpected localizations. Acquire ex vivo images of all excised lymph nodes in a sequential fashion for the presence of fluorescence. Longer exposure times can be used when capturing still images. The sentinel lymph node is sent in for histopathological analyses to detect the presence or absence of tumor cells. The power of intraoperative detection of a sentinel lymph node with this protocol of multispectral fluorescence imaging is demonstrated in this example of an in vivo multispectral fluorescence image of a lymph node in vulvar cancer. The fluorescent lymph node in the inguinal region before excision is clearly visualized. In this short movie, we show real-time detection of the sentinel lymph node based on fluorescence in a patient with cervical cancer. Here, we depict an ex vivo image of a lymph node in cervical cancer. The color image of the lymph node was superimposed by the fluorescence image of the very same lymph node using a pseudocolor scale to produce a clear image with high signal-to-background ratio.
This technique not only paved the way for researchers in the field of surgical oncology of image-guided resection of the sentinel lymph node, but it also provides possibilities for specific tumor-targeted imaging, for tumor margin assessment and patient-tailored interventions in patients with solid tumors and possible local regional metastases.
So after watching this video, you should have a good impression of the real-time intraoperative fluorescence imaging of the sentinel lymph node in gynecologic cancer.